All right, hi everyone. Welcome back to another topic video. This one on balancing redox reactions. We're going to balance this one today in a basic medium. I chose to do basic for this as opposed to acidic because if you can balance for basic, you can balance in acidic, okay? So we're going to do basic today, and hint, 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 basic is on your test next week. So we're doing this example in basic. This is not from the workbook. This is one I just found online because I've done the ones in the workbook in class. I've done several of them in class. So I'm going to leave the rest of them for you to try yourself. I just found an example online on a worksheet, and we're going to go ahead and do this one. They're basically all the exact same, right? So it doesn't really matter which one we choose. All right, so let's go ahead. First thing you have to do is give everything in your redox reaction an oxidation number. So thinking about the set of rules that we went through, starting from the top, working your way down because the order of the rules is important. Single elements from the periodic table are neutral, they're zero. There's no single elements here. Single ions are the charge of the ion. So we do have a couple. So iron 2 plus would be a plus 2, chromium 3 plus would be a plus 3, and then iron 3 plus would be a plus 3. Group 1, 2, or 3 elements are plus 1, plus 2, plus 3. We have no group 1, 2, or 3. Oxygen in a compound is minus 2. In this particular one here, this oxygen is minus 2. We did talk about how oxygen can be other things besides minus 2 for peroxides and superoxides, but you're not going to get peroxides or superoxides on your test or your final. So for our purposes, oxygen will always be minus 2. There is no rule for chromium, so use algebra, do a little side, example here, xy plus b kind of thing to figure out what chromium is. In this particular ion, chromium is plus 6, okay? Once everything has an oxidation number, you're going to look and see what changes from left side to right side. So chromium starts at a 6 and finishes at a plus 3. Iron starts at a 2, finishes at a plus 3. One should be going up. One oxidation number is increasing. One is reducing, going down. OXI, increase. That's your oxidation. So from 2 to 3 for iron, that's an increase in number. That is the oxidation. It's just like a number line. So from 2 to 3 is 1 electron. Chromium is going from 6 to 3. That's reducing. It's going down. Reduction. And again, just like a number line, from 6 to 3 is 3 electrons. You have to be able to identify this part of your question first before you can get into even balancing. Right? You need to know what's happening, what's gaining, and what's losing electrons. Once you have that done, you're going to write your oxidation half and your reduction half reaction, because we are doing this through the half reaction method. There is a secondary method called the ion exchange method, which we're not going to do. We're doing the oxidation and reduction half reaction method. Starting for your oxidation, so we start with Fe2 plus. Fe2 plus becomes Fe3 plus 1 electron, right? That's an oxidation. It lost 1 electron. So we write our electron as a product. The reduction is dichromate, Cr2O7, 2 minus, plus 3, that's a reduction, it's gaining, plus 3 electrons, becomes Cr3 plus. Okay, at this point we're going to try and balance these reactions for 3 things: atoms, electrons, and charge. In that order, specifically. Atoms first, then electrons. If you've done those 2 correctly, charge comes out in the wash. It's all good. It'll balance itself. I like to separate my balancing so that I know if I make a mistake, hopefully I can go back and figure out where that mistake is. I'm going to move my paper down a little bit here so I can make some room. Okay, oxidation half. 1 iron, left side, right side. It's all good. Don't need to add anything. There is no oxygen, hydrogen to balance, so my oxidation half is good, just like it is. I don't have to change anything, but I will rewrite it on my new line. My reduction has one chromium on the right side and 2 chromiums on my left side. So I'm going to change the number of chromium, and when I do that, like I mentioned in class, if you change the number of an element other than a hydrogen or oxygen, you have to change the number of electrons at the same time. Otherwise, when you get down to balancing the charge, it's not going to work out. You're going to be confused and you're going to be like, where did that go? Why is this not equal? This is why. So I'm changing the number of chromium, Cr2O7 2 minus. I'm going to leave my electrons for a second. I'm going to leave a big space here, and I'm going to put 2 Cr3 plus, so that my chromiums are now the same. But because I changed the number of chromium, I have to go back and change my number of electrons accordingly. So whatever number you're using to balance, in this case it's a 2, I'm going to multiply that by my electrons for a total of 6. Okay, very important. Don't forget that step. If you do, your charge will not work out. Oxygen, 7, left side, 0, right side. I'm going to add water, 7 water on my product side to balance the number of oxygen, but now I've also added hydrogen, so I have to go back to the left side, and I'm going to add 14 H plus. Now if I look and check, all the chromium, hydrogen, and oxygen should be the same number on both sides, which they are. So atoms are balanced. At this point, I would make a little note to myself. I would write it. Atoms, done, check. So I know if I'm going back and I'm trying to find a mistake, this is the part of my question where I balance the atoms. Okay, hopefully that will help and you won't get mixed up. If you are making a mistake and you've got to try to find it, maybe that'll help you. Okay, for my electrons, I have 1 in my oxidation and 6 in my reduction. Very easily, to make both of these the same, I can very easily put a 6 in front of all my oxidation, right? Multiply everything by 6. So this one is now a 6. And if you want, you can make a little note to yourself, times 6, so that you know what you've done here. I want both electrons to be the same in both equations. So they're both 6 now. That's good. Again, I'm going to make a little note to myself on the side. Electrons, done, balanced. Now, if I have done those 2 steps correctly, my charge should work out. You can add up all the oxidation numbers on both sides of the equation. They should be equal. If they're not, you got to go back and try to find where you made your mistake. 6 times plus 2, so plus 12, left side. 6 times plus 3, that's plus 18. 6 electrons is like a minus 6, so a plus 18 and a minus 6 is the plus 12. Both same. Charge good. Dichromate is a minus 2. 6 electrons is a minus 6, so that's a minus 8 total. Plus 14 from the hydrogens gives me plus 6 overall. 2 times 3, 6, water neutral. Charge is good, 6 and 6. So again, I'm going to make a little note to myself. Charge. Good. Everything's great. At this point, you're going to cancel what you can cancel, add what you can add. This would be how we would finish if we balanced for acidic. So electrons are always going to cancel. Okay, one's on left side, one's on right side. That should always happen. Everything else is different here. So I'm just going to rewrite this 6Fe2 plus dichromate plus the 14 hydrogen. Okay, and we get 6Fe3 plus. Well, we have 2 Cr3 plus and 7 water. So, like I said, if we were balancing for acidic, this is where we would stop. This is now balanced for acidic. I want to balance this in basic. Okay, they're essentially both the same. So if you can balance for basic, you can balance in acidic. This is why we're going to do basic, because it's like one step further, one step harder. If you want to, at this point, you can check the charge again on left side and right side. Make sure everything is equal. If it is, you're safe to go on to your last step for basic. This is 12 and a 14, so that's 26, and a minus 2. So 24 plus 24, left side, 18 and 6, 24, right side. Good. So charge is good. For balancing in basic, the next rule is whatever your number of hydrogen, H plus, is, you're going to add the same number of OH minus, but you're going to add it to both sides of your reaction. So I have 14 H plus. I'm going to add 14 OH minus. I'm kind of just write it just a little bit underneath here so it kind of looks like it's all on the reactant side. And same on the product side, I'll just put it right on the end, 14 OH minus. Make sure you can see that. There we go. 14 H plus and 14 OH minus will make 14 water. So those two come together, makes 14 water molecules. I have 7 on the opposite side already, 7 H2O on my product side. So those 7 are gone. They're going to cancel with 7 of those 14, leaving 7 left over. Now I would rewrite my equation. This is now balanced for basic. And if you check your charge, once again, it should be equal, and then you know you got the right answer. So once I get this wrote out, let's see what we got. All right, there we go. Make sure you can see all that. Good. And again, let's add up the charge. So 6 times 2 is 12. And the dichromate is a minus 2. So that would give me a plus 10 on my reactant side. 6 times 3 is 18. And 2 times 3 is 6. So that's 24. And the 14 OH minus is a negative 14. So 24 and a minus 14 gives me a plus 10. So I am all good. Everything is right. It's very unlikely that you would end up with the charge being balanced at the end and this not being the correct equation. Okay, that's very unlikely. So if you're checking the charge all the way through, it's easier to make sure you're actually getting your correct answer at the end. Now, if by some chance you didn't get the charge to work out, some common things you're going to want to look for, common areas of where you might make a mistake. Check to see that you're writing down the charges correctly as you're writing everything on a new line. So Cr2O7 minus, maybe you wrote a 1 minus here instead of a 2 minus. All right, or Fe2 plus, maybe you wrote Fe plus or Fe3 plus. Maybe you got them mixed up, confused. Very common, that happens. When you are balancing for your electrons, so if I go back up to that step where I added everything with a 6, make sure you did actually multiply everything the whole way through in your equation by that coefficient. Another very common mistake. And then the last area that you should probably check when you're balancing your atoms, right? Did you add the appropriate number of water and the appropriate H plus as you're going through? Okay, make sure that you check these very common areas that people typically make a mistake in if they are doing this type of question. If you've checked everything like that and all your charges are good and you're happy with everything, there's no reason why your charge shouldn't balance out at the end. But it is really common and easy to make a mistake, and kind of like a silly mistake, right? You don't want to rush this example, and you don't want to kind of jam everything into one line. Take the time to rewrite your equations, as you do each step, so that if you do make a mistake, it's a little bit easier to go back and hopefully find, where you have made that mistake. Definitely try the questions from the workbook. What I would suggest is doing both of them, acidic and then basic, and do all of them like that. Once you finish them, put it aside. Maybe the next day, do them again. Put it aside, do them again the next day and the next day, and just keep trying them. They're very repetitive, and if you can do one of them, there's no reason why you can't do any of them, okay? So you just need practice, and hopefully this video will be helpful. Definitely do your workbook, and you can check your solutions online if you need to. Don't forget to email if you have questions. Good luck studying for your quiz next week, and as always, thanks for watching.